The universe, vast and boundless, is full of mysteries waiting to be unraveled. For centuries, the idea of extraterrestrial life has captivated human imagination. When we look out into the heavens, we often find ourselves asking the same question: are we alone? While we've set our sights on distant planets in the search for answers, there's another avenue we've only recently begun to fully explore: moons. Moons are more than just frozen rocks or barren satellites. They may hold the key to life beyond Earth. And what if the answer to our most profound question lies not on a distant planet, but on the icy surface of a moon orbiting a gas giant? The search for habitable moons is one of the most exciting frontiers in space exploration today. These moons, like the ones orbiting Jupiter and Saturn, offer the possibility of water, energy, and chemical building blocks, the ingredients for life. In a way, they represent a second chance for habitability in our solar system, where moons orbit planets far outside the traditional habitable zone around stars, yet still retain the conditions necessary to host life. For life to exist as we know it, water is an essential ingredient. In the search for life beyond Earth, the habitable zone is one of the most critical areas to investigate. This is the region around a star where conditions are just right for liquid water to exist on a planet's surface, not too hot and not too cold. But this zone doesn't apply only to planets. It extends to moons as well. The moons of gas giants, which orbit planets far from the sun, could harbor life, not because they sit within the traditional habitable zone of a star, but because they benefit from other, more mysterious processes that allow them to sustain liquid water beneath their icy shells. While many moons in the outer solar system may appear inhospitable at first glance, cold, dark, and far from the warmth of the sun, their potential for harboring life is anything but straightforward. Some moons are subject to powerful tidal forces generated by the gravitational pull of their parent planets. These tidal interactions create heat, keeping subsurface oceans liquid despite the extreme cold. This process is known as tidal heating. It's a natural mechanism that could provide just enough energy to sustain life beneath the frozen surfaces of moons like Europa and Enceladus. Among the most promising moons in our solar system are Europa, a moon of Jupiter, and Enceladus, one of Saturn's moons. These icy worlds have long captivated scientists, who now believe that beneath their frozen exteriors lies something far more important: liquid water. Europa is a world encrusted in ice, but this ice conceals an ocean that stretches deep below the surface. Europa's thin atmosphere, composed primarily of oxygen, offers no warmth, but the gravitational tug of Jupiter exerts immense tidal forces on the moon, causing its icy shell to flex and shift. This flexing generates enough heat to prevent the ocean beneath the ice from freezing. Scientists have theorized that the ocean could be a prime environment for life, sheltered from the harsh radiation of space and warmed by the energy generated from this tidal heating. It's an alien world that could, one day, harbor organisms in its cold, dark waters. Enceladus, though much smaller than Europa, holds similar secrets. The discovery of water geysers shooting into space from cracks at its southern pole has revolutionized our understanding of this tiny moon. The plumes contain water vapor, organic compounds, and even salts, all of which are essential for life. These geysers are believed to be linked to a subsurface ocean, kept liquid by tidal heating from Saturn's gravitational influence. The fact that this ocean is actively venting into space offers a rare opportunity. We can sample its contents without ever setting foot on the surface. Both of these moons are now at the forefront of the search for life. The question is not if life exists there, but whether it could be microbial, deep beneath the ice, and waiting for discovery. Then there is Titan. Saturn's largest moon is unlike any other in the solar system. While Europa and Enceladus rely on water beneath their surfaces, Titan takes an entirely different approach. This moon is wrapped in a thick, nitrogen-rich atmosphere, a hazy shroud that shields its surface from the cold vacuum of space. Titan is a world of liquid methane and ethane, hydrocarbons that form rivers, lakes, and seas on its surface, the closest we know of to a second Earth in terms of its complex chemistry. It's easy to imagine Titan as an inhospitable world, with temperatures far below freezing and clouds of methane swirling through its skies. Yet, Titan presents something truly unique: the possibility of life that is not carbon-based, but methane-based. Life on Titan, if it exists, may not require water to thrive. Instead, the thick atmosphere and liquid hydrocarbons could serve as the perfect medium for a different kind of biochemistry. Titan is also a world of contrasts. Despite its freezing surface temperatures, its atmosphere offers protection, and its complex organic chemistry offers the potential for the raw materials necessary for life to form. Titan is not just a world we want to explore, but a reminder that life can take forms we can hardly imagine. As we look beyond our own solar system, the search for habitable moons expands even further. Thousands of exoplanets have already been discovered in what is known as the habitable zone, the region around a star where liquid water could exist on the surface of a planet. But many of these planets also have moons, and these moons could very well be the next frontier in our quest for life. Just like the moons of Jupiter and Saturn, moons in other star systems may orbit planets that lie within the habitable zone of their stars, but the moons themselves may possess conditions far more suited for life. These exomoons may have their own liquid oceans, or they may be kept warm by similar tidal forces from their parent planets. The question is, do these moons harbor the right conditions for life to form, evolve, and survive? And, perhaps even more exciting, are they home to the kinds of complex systems we see on Earth? The technology we need to explore exomoons is still in development, but as telescopes improve and our ability to detect distant planets and moons increases, the search for habitable moons around other stars may soon become a reality. How do we search for life on moons so distant, so alien to our understanding of life? It starts with exploration. NASA's Europa Clipper mission and the European Space Agency's JUICE spacecraft will soon conduct detailed flybys of Europa, Ganymede, and Callisto, collecting data on the composition of their ice shells, their potential oceans, and the materials they contain. Meanwhile, Titan's unique atmosphere and surface conditions make it an ideal candidate for future exploration. The Dragonfly mission will send a drone-like rotorcraft to Titan, flying through its thick atmosphere to sample the surface and search for the chemical fingerprints of life, past or present. These missions are just the beginning, and as technology advances, humanity will one day have the tools to drill into the icy worlds of Europa and Enceladus and to study the chemistry of distant exomoons. In the distant future, moons might not only be our destinations for scientific exploration, but they could become the homes of human colonies. Imagine Europa, with its subsurface oceans, as the site of a research outpost. The thick ice crust could provide natural protection from the harsh radiation of space, while the ocean below might hold the key to discovering alien life or learning to survive in the extreme conditions of another world. Titan, with its thick atmosphere, could offer humans a chance to study alien chemistry and life. Its resources, methane, ethane, and nitrogen, might one day be used to create fuel or even a sustainable atmosphere for future explorers. The search for habitable moons isn't just about discovering life in the universe. It's about unlocking the potential for these moons to become our partners in humanity's quest to explore the cosmos and perhaps, one day, to call another world home.